This lecture video follows right along with your Chapter 9, Section 2 lecture notes. We are going to learn how to write radicals using rational exponents. For any integer n greater than 1, we define a raised to the exponent of 1 over n to be the nth root of a. For example, 64 raised to the exponent of 1 over 3 can be rewritten as the cube root of 64. And since 64 is equal to 4 cubed, this is simply 4. Negative 32x to the 15th raised to the exponent of 1 over 5 can also be written as a radical expression. This is the fifth root of negative 32x to the 15th. And since negative 32 is equal to negative 2 to the 5th and x to the 15th is x cubed to the 5th, this expression simplifies to negative 2x cubed. In example 2, we are asked to do the exact opposite. This time we have a radical expression and we are going to write it using rational exponents. Here we have the ninth root of a, which we can rewrite as a raised to the exponent of 1 over 9. We can also have rational exponents with integers other than 1 in the numerator. For any integers m and n where n is greater than 1, we define a raised to the exponent of m over n to be the nth root of a raised to the exponent of m. This is equivalent to the nth root of a to the m. In other words, when we have a rational exponent of m over n, the denominator of the exponent is the root, while the numerator of the exponent is a power. When we are simplifying expressions of this type, try to take the nth root of a first when it's possible. When it's not possible, go ahead and raise a to the power of m first and then try to take the nth root. Let's take a look at example 3. Here we have 81 times a to the 36th times b to the 12th, all raised to the exponent of 3 over 4. Remember that the denominator of the exponent is the root. So rewriting this as a radical expression, we will have a fourth root of 81 a to the 36th b to the 12th, and the numerator is the power. So we'll raise everything to the exponent of 3. Consider that 81 is equal to 3 to the 4th. A to the 36th can be written as a to the 9th to the 4th, and b to the 12th could be rewritten as b cubed to the 4th. So this simplifies to become 3a to the 9th b cubed, all raised to the third power. And simplifying, we have 3 to the third, or 27, a to the 9th to the third, which is a to the 27th, and b cubed cubed, which is b to the 9th. Let's take a look at example 4. We will start by simplifying x raised to the exponent of 3 over 4 times x raised to an exponent of 7 over 10. All of our rules of exponents still apply. So having the same base of x, we can add the exponents. This becomes x raised to the exponent of 3 over 4 plus 7 over 10. Let's consider how we might add the two fractions 3 over 4 and 7/10. The least common multiple of 4 and 10 is 20, so we'll get a common denominator of 20. Multiplying 3/4 by 5 over 5, we have 15 over 20. Multiplying 7/10 by 2 over 2, we have 14 over 20. Now we can combine the numerators since we have a common denominator. This becomes 29 over 20. So back to our exponents, we have x raised to the exponent of 29 over 20. Now let's simplify this next expression. We can start by distributing the exponent of 2 over 3 to both our x and y variables. That is, x to the 6 over 7 to the 2/3 times y to the 3 over 8 to the 2/3. Using our rules of exponents, we know we can multiply these two exponents together. This becomes x raised to the exponent of 6 over 7 times 2 over 3. Similarly, we have y raised to the exponent of 3 over 8 times 2 over 3. Multiplying, this is x raised to the exponent of 12 over 21, and y raised to an exponent of 6 over 24. Simplifying these fractions, both 12 and 21 are divisible by 3. And dividing them both by 3, we have x raised to the exponent of 4 over 7. 6 and 24 are both divisible by 6, so this simplifies to become y to the exponent of 1 over 4. Let's take a look at two more examples. Here we have 32 raised to an exponent of negative 3/5. Using our rules of exponents, we know that this is equivalent to 1 over 32 raised to an exponent of positive 3/5. The 5 in this case represents a root, while the 3 in this case represents a power. So this is 1 over the 5th root of 32 cubed. The 5th root of 32 is simply 2, so we have 1 over 2 cubed. And 2 cubed is 8, so this expression simplifies to 1 over 8. Let's head over to our last example. In example 6, we are multiplying two radical expressions together, except they do not have matching roots. And since they do not match, we cannot simply combine them by multiplying the insides together like we can when they do match. Let's see how rational exponents can help us simplify this expression. We first write the 4th root of x as x raised to the exponent of 1 over 4. And we can rewrite the 5th root of x cubed as x raised to the exponent of 3 over 5. Now, using our properties of exponents, we know we can add these two exponents together and have x raised to the exponent of 1 over 4 plus 3 over 5. Let's think about a common denominator to combine 1/4 and 3/5. 4 and 5 have a least common multiple of 20, so that will be our common denominator. Multiplying 1/4 by 5 over 5, we have 5 over 20. And multiplying 3/5 by 4 over 4 gives us 12 over 20. Adding these two fractions together, we have 17 over 20. Back to our rational exponents, this becomes x raised to the exponent of 17 over 20. To rewrite this back in radical notation, we need 20 as our root and 17 as our power. So we have the 20th root of x to the 17th. And that will conclude this lecture video on rational exponents.